Near field communication, NFC is a very short range data communication, around 10 centimeter or less, with the help of contactless RF communication technology. The NFC is also based on RFID technology, but it uses two-way communication unlike RFID. So the technology allows a simple, rapid, intuitive, and easily secureable communication between two electronic devices. So in the figure, you can see there is a card and another one is the platform where we rest our card. We bring close our card to that platform. So this is an example of NFC. It uses variations in the magnetic field to provide communication between two NFC-enabled devices. NFC operates over same frequencies as RFID operates in, 13.56 megahertz. So this is the same frequency we were using. The the reader and the tag are communicating over a frequency of 13.56 megahertz. There are two modes of operations. One is active mode and then another one is passive mode. And these modes are same as we have discussed in RFID. In active mode, both devices generate magnetic field. Many wearable mobile devices use active NFC, near field communication. One major use of NFC in mobile devices is storing and transferring the credit card information. And passive mode, I don't know, have you seen those scenario or not? You can use your card for your payment, while on the counter there is a reader. You just bring your card closer to that reader, and it can communicate, and your payment will be go through. Okay, so in passive mode, uh, in active mode, the tag and reader both will have their own power supply. In passive mode, only one device generates a magnetic field, and the other uses load modulation to transfer the data. Device will will get its power from the source, um, like from reader. For example, student ID cards can use NFC technology. If a student taps the card on the bus, the card is passively transferring information through NFC to the bus system's active card reader. You can see in the previous image, it works like that. It works like this. Okay, so move on. The passive mode is useful in battery powered devices because it uses less power, and the IoT devices also require less power to operate. Okay, so this is a summary table for NFC near field communication. The frequency at which NFC works is 13.56 megahertz at rates from 106 kilobytes to 424 kilobytes, and the range is less than 0.2 meter. And the example is smart wallets, cards, action tags, access control when you want to open a door or when you want to open a gate. So you can implement NFC technology to access the gate. Okay, so it is another, as I discussed, we are studying, we are exploring the physical layer, some of the physical layers physical layer technologies in wireless sensor network. We studied Zigbee, IEEE 2.15.4. We have gone through RFID. We also studied explored the NFC, and now uh, we are going through Bluetooth Low Energy. So Bluetooth is a wireless technology standard for exchanging data over short distance amongst different mobile devices. So Bluetooth is a wireless technology standard for exchanging data over short distances among fixed and mobile devices. So the mobile devices, you already know that, and the fixed device could be your television, or it could be your speaker. Speaker is fixed at some location in your room, but enabled with Bluetooth. So creating personal area network with a high level of security. If you when you want to create a PAN with a high level security, the BLE is the best candidate. The Bluetooth Low Energy, also known as Bluetooth Smart, is developed and proposed by Bluetooth SIG, Special Interest Group. BLE is a low power version of original 2.4 gigahertz Bluetooth. BLE was introduced as Bluetooth 4.0 in year 2011. So, and the BLE was known as Bluetooth 4.0 in 2011. BLE has been designed to transfer low volumes of data at high speed, 1 megabits per second, where one device might be connected to several devices in a star topology layout. BLE has a range limited to 100 meters, so it usually suits for PAN. So the device connected through BLE go in sleep mode when not transferring data. So let's look. When the device is not communicating, both devices will be asleep so that they can uh, reduce the power consumption. Uh, and these are three or four limitations in IoT. Number one is we have restrictions in power, we have limitation in processing, and we have limitation in range and the memory as well. So BLE is one of the best candidates in when you are designing your personal area network. When connected, BLE devices may have connection time for only few milliseconds compared to average time of 100 milliseconds in classic Bluetooth. So the classic Bluetooth takes more time, and the BLE takes less time due to short connection time and high data rate. BLE is extremely power efficient compared to any other competing protocol. So BLE is designed for IoT devices that could be powered for few years on a small battery, like 1.5 volt or 3 volt batteries. You guys already know those batteries. So the BLE protocol stack has two parts. One is controller and another is host. So we are now going to study the BLE protocol. The BLE protocol has two parts. One is controller and another is host. The physical and link layer are implemented in controller part. The controller is typically a chip, a system on chip with a radio and Bluetooth devices. The rest of things like GAP, GAT, Services Security Manager are included in the host part. So in the host part, we have GAP, we have gate services. Uh, those are in the host part, and in the controller part, we have uh, physical and link layer. So this is a stack structure of Bluetooth. You can see this part is a controller. Let me grab a pen. So this is a controller, and this is the host part, and this is an application layer. And in host part, you can see in the host part, you can see generic access profile, gap, and generic attribute profile, gate. So generic access profile responsibility is to sense other Bluetooth devices in the range, and the generic attribute profile is a service and is responsible to provide services and characteristics to other devices that is in the range of the Bluetooth device. So frequency, it works in on 2.4 gigahertz. Range is 1 to 100 meter. And examples where we can apply them, where they can be used: hand-free headsets, key dongles, fitness trackers. Can you give me an example of fitness trackers? It might be something that is mounted on your wrist to see the pulse rate and send it to your mobile device. Or it could be any other device that can sense the respiration rate and send it to your mobile device. Or it could be another uh, module that can count your steps and then send it to your mobile device via Bluetooth. So this can be used in many applications.
पीछे कर लाइट जला ले रोशनी बारिश आ गई लाइट जला लो इथे लाइट जला ले तू अपने को तो बैठ जा गर्मी है सेक आ रहा है तो फिर मैं काम नहीं कर रही वो नजर नहीं आ रही नजर नहीं लाइट अम्मी लाइट जला ले.
Okay, so is there any question? All right, the next is the GPS. Do you know about GPS? All right, so let's take a radar. Let's suppose we have this radar. Now, this is our object. Sorry. I'm looking for the pen, where to grab the pen. This is an object, and this one is our radar. This is the radar. But the radar can see there is an object. Let's suppose the distance of this is 1 meter and the distance to this is 2 meters. Let's suppose, or you can say 1 kilometer. So the outer circle is 2 kilometers away and the inner circle is 1 kilometer away. Just take an assumption. So how far our object is from radar? It is 2 kilometers. So the radar can detect that an object is away from 2 kilometers, but it doesn't know in which direction. From its calculation, we can assume that we can not assume, we can have many locations that are away from 2 kilometers. This could be this one, this could be that point, or this could be that point. So we are not sure. We cannot make sure that where is actually that object by using a single radar. So if I place another radar here, if I place another one, let's take this. So what about the second one radar? The first circle is 1 kilometer, and then 2 kilometer, and the third one is third kilometer. And that is the second radar. This is 1 kilometer, this is 2 kilometer, and this is third kilometer. So this the second one, second radars can also detect the object that it is 3 kilometer away, but where? It could be on any place on the circumference of the third, on the 3 kilometer. So when we are using two, we will more precise, and we will see that this could be, the object could be at this point or at this point. Because where the two radars intersect each other, that would be the location of the object. If we use two radar, then there will be two